This is my house. It's an Italianate built in 1876. It has balloon framing, meaning the studs span from the foundation to the roof, and it's insulated with cellulose. The house is kind of unique for its time, in that most of the windows were put on the south side to maximize solar heat gain. Some of the major sources of heat loss are the windows. This is an original single-pane window. Most of these have been replaced with insulated windows and vinyl jambs, which are much more efficient. A significant amount of heat is also lost through the doors. Here, the door and jamb don't align perfectly, allowing hot air to escape. To combat this, we put up storm doors in the winter. The house was heated with a coal furnace until 1974, when it was replaced by a previous owner with an oil furnace. Currently, there is a national 30% rebate in the form of a tax credit for the installation of a geothermal heating system. My parents have wanted to switch to geothermal for a while, and finally decided to start the project this summer before the rebate offer is terminated at the end of the year. To reduce the significant cost of the project, my dad did a lot of the work himself, including calculations for the system, laying the pipes in the trenches, and the ductwork. A 101,000 BTU heating load is required for the 2,500 square foot home, which is met with a 35,000 BTU soapstone wood stove, a 61,723 BTU heat pump, and a 34,121 BTU auxiliary electric resistance plummet heater. The heat pump unit is a Geostar, which is the only variable speed system on the market. The compressor, blower, and loop pump speed are frequency driven and each individually controlled by the internal computer, which continually makes adjustments to ensure that the entire system is running optimally. The variable speed system helps the unit achieve a coefficient of performance of 5.3, which is high in comparison to other models. This is a closed-loop system which contains a water and propylene glycol mixture. There are 5 loops of pipe, each of which is 800 feet long and lays in its own 400-foot long trench. The trenches are a minimum of 6 feet deep, but average between 6.5 and 7 feet. The water returns from the ground at 50 degrees and is brought back to the unit, where the heat is extracted and transferred to the cool return air. After being heated, the air travels to the plenum, where it is distributed to the rest of the house. The house is separated into 2 zones, the upstairs and downstairs. The airflow to each zone is regulated with motorized dampers, which are monitored by these control boxes. The hot air travels to registers, such as this, in the zone where it is needed, and cool air is returned to the unit through other registers. This is the thermostat that controls the system. In addition to monitoring indoor temperature, it also displays the outdoor temperature in conjunction with another thermometer. It also tracks the airflows and daily, weekly, monthly, and yearly energy usage. We programmed in the cost of electricity, 11 cents per kilowatt hour, and it also tracks the cost of operating the system. Since the system was only finished a little over a week ago, there is not yet information available on its long-term performance. However, over the past 9 days, the unit has used an average of 10.75 kilowatt hours per day, has output an average of 36,676 BTUs per day, and the total cost of operating the system thus far is $10.65. Not only is this system cost-effective in the long run compared to the oil furnace, it's also an exciting step towards reducing our carbon footprint and moving towards renewable energy. The next improvement will be updating the water heating system. When the rest of the oil in the tank is used up, this water heater will be replaced with an air-sourced heat pump water heater that will utilize the basement air as the heat source.